Okay, here we go, electron configuration, here we go. Shortened periods that I don't have as much time, so we're going to try to get this done to help you guys. Get out Part C on demand electron configuration, this paper right here. I would also take out the periodic table I gave you, the two-sided periodic table that I gave you. Get that out also. Okay, this is a higher level way to show the arrangement of electrons and valence electrons in different atoms and ions. And a shorthand way to show it. So we're going to talk about this. First time I've done it here in my career, so I'm kind of excited by doing something new for the first time. And we're able to fit stuff like this in to help you to get ready for the high school because of Part C on demand. We've saved time in class with some skills allowing us to do more. So this is one of the new skills we've done this year. We're going to do this year, so it's kind of exciting. Okay, let's start off with this. And I know it's written kind of small, but I'm a one-man camera operation here. You're going to see one large number, that's the energy level. Okay, the level which the electrons are. We talked about the first level, the second level, the third level, the fourth level, and so on. There's going to be something called a suborbital within that level. We have the different suborbitals, the S block, S in Sam, the P block, the D block, the F block. And you're going to notice that the S block can hold two. There's two electrons on each level that are classified as the S block. The P block, there's going to be up to 6 electrons per level that can be put into the P block. Then we get higher level, and we don't do too many of these, we do some. The D block and the F block, the D block usually occurs in the transition metal level. And we can fit an extra 10 electrons into that suborbital. In the F block we get to lanthanides, actinides, that gets a little bit crazy. We can fit up to 14 within that suborbital. So we're going to start off with the basics first and go from there. So here's what we're going to do. Take a look here, I've broken it down into four, right? 4 different sections. So let's start with the first one. It says sulfur. Sulfur. Now, what I would do is have this in front of you and turn to the back where you have your periodic table. You're going to see a blank periodic table showing different levels, and you're going to see this diagonal chart. I want you to take a look at that. So the first thing I want to do with sulfur is this. I want to identify how many electrons sulfur has. So you look at your periodic table, I'm looking over there. Sulfur's got atomic number of 16. Right? So it's got 16 protons and the atom has 16 electrons. Okay, so the first thing I would do is write down 16 electrons next to sulfur. Okay? And here's what I'm going to show. I'm going to draw it out first. Here's the first level for sulfur. Here's the nucleus. In the first level you've got 2 electrons. This is energy level 1. And within that level you've got suborbitals, okay, or subshells. And we're going to call them the S block. So they're going to get a little S, S. So I've got 14 more I got to show. Let's open up the next level. Level 2, energy level 2. Here we go. Energy level 2. We've got, and in each level, you've got an S block. So watch this. 1, 2. S block, S block. We said in each level, you can hold 2 electrons. But now we're getting into the P block because I can hold more in this level. So we're going to go 3, 4, 5, 6, 7, 8. These remaining electrons are found in the P block. 1, 2, 3, 4, 5, 6. So now I've got 6 in the P block. Okay? So now I've got 2 in the first level in the S block, 2s2, 2 in the second level plus 6 more, 2p6. And now we have how many electrons? 10. We got to open up a new level. Oh my gosh. 1, 2. We're in the S block again. 3s1, 3s2. 2 in the S. Now we're to P block again. So how many we have? 2, 8 is 10, plus 2 more is 12. I need 4 more electrons. So then you go 3, 4, 5. Hold on. Is that it? 2, 8 is 10, 11, 12, 13, 14, 15, 16. Okay, so now we're in the P block. 1, 2, Hold on. 3, 4. So let's count. 2 in the first, 8 in the second. We need 6 more. 1, 2, 3, 4, 5, 6. 16 electrons. Now, with sulfur, sulfur is in group 16. It should have 6 valence electrons. 1, 2, 3, 4, 5, 6. But within each energy level, you've got suborbitals when they whiz around and rotate around the nucleus. The first block you have is S. The S can only hold 2. We only have 2 here for S, 2 here for S, 2 here for S. Then for the P block can hold up to 6. 1, 2, 3, 4, 5, 6. Here we go. 1, 2, 3, 4. Can I fit 2 more? 5, 6, but we don't have those yet. So the configuration is as follows for sulfur. Start at 1. Now look at your periodic table. Up top, and again it's hard because I don't have the periodic table up here. 1s, energy level 1, s2. That covers hydrogen and helium. Then go down to the second period. 2s2. Okay? So we're still in the S block. Each S block can hold 2 per level. Now we're in the second level. But the second level overall can hold 8. So now we've got to go 2p, how many are left? I have 2 out of 8, so now I'm going to go 2p6. 2p6. Okay, so now I'm currently at neon. So take a look at that periodic table. Go down to the third. Go down to where sodium would be. Now we're on the third level. And every time you start a level, you start off with the S block. So 3s. How many can be held in this S subblock? S block, 2. 2. Am I still on 3? Go across now to where aluminum is. Or 3p. How many are in the P suborbital in the third level? 1, 2, 3, 4. 4. Count it up. 2, 4, 10, 12, 16. So the arrangement for sulfur, 1s2, 2s2, 2p6, 3s2, 3p4. So on the first level, I've got 2 in the S suborbital. The second level, I've got 8. Here's my 8. 2 plus 6 is 8. 2 in the S suborbital, subshell. 6 in the P block, the P suborbital, for a total of 8 on the second level. Now, and that's right here. Here's here. Now on the third level, first S block starts as 2. So here's my 1, 2. Now the P block, which can hold up to 6. We've got 4 more. So right here, these right here are my number of valence electrons in the outermost level. 6 valence electrons, because in the outermost level I've got 6. So sulfur has 6 valence electrons in group 16. That's its diagram. Okay? Very simple, easy. It's a little bit different. All right, I'm going to erase that, take a look at it. And we're going to do neon together next. Neon, we're going to skip down to neon. I'm going to erase that. Neon. Here we go. Neon. Take a look at the periodic table. It's a noble gas. It's got 10 electrons. Okay? So now a little quick drawing of neon. Here's the nucleus, right? Okay? First level can hold up to 2. Here's 2. Well, it's not even assigned suborbitals yet. Okay? Second level, up to 8. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. Got a full outer shell, so it's not reactive. How are those electrons arranged? So in energy level 1, this is energy level 1. Here's energy level 2. First level, you've got a capacity of 2, and you always start off with the S block. 2 per level. So we're going to call this first electron on the S subblock, suborbital. Second one right there. We're at capacity. Open up to the next level. Again, start off in the S block, 2 per level. So we'll classify this as an S block. We'll classify that as an S block. Suborbital. So now we have 2 we've accounted for. We've got 6 more in the second level because it can hold up to 8. But now we've run out of room on the S block. Now we're on the P block. And let's show this in orange. Here we go. Ready? P block electron. 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 So now you've got 2 plus 8 is 10. And in each level, the first 2 are going to be S block. The next 6 are going to be P block. Here, you've got a total of 10. So now write it. You've got 1, that's your energy level. How many electrons in the first level? 2. 1s, 2. Open up to the second level, level 2. 2. First 2 in the suborbital are s, 2s, 2. Still on 2. What level now? What suborbital? P. How many left? 6. So your answer for neon is 1s2, 2s2, 2p6. Proof it by counting the electrons. 2, 4, 10. 10 total electrons, you're good to go. Which ones are the valence electrons? Outer shell, 2 plus 6, 8 valence electrons right there. Okay? Very simple, very easy. All right? Take a look at that. So again, S block comes first in each level. Can hold 2, can hold 2. P block comes next if there's more room, as there is. The P block holds up to 6. Okay? I'm going to erase that. Next one we're going to do gets a little interesting. We'll talk a little bit more about this in class. Go back up to copper. See you later, punk. I'm out of here. The coppers are coming. Copper. See you later, punk. I'm out of here. The coppers are coming. Copper's got an atomic number of 29, so we've got to work with 29 electrons. Oh boy. Okay. So really take a good look at the back of the periodic table, at the arrangement. Now, 29 electrons. So we're going to start off in level 1, S block 2. Okay? That accounts for hydrogen and helium. Now skip down to period 2. Look on that chart up top. Now you've got energy level 2. Energy level 2 can hold up to 8 at this point. So the S block we start off with first can only hold 2, because 2 per S block on each level. Okay? Now we're going to continue across to boron all the way through neon. We're still on energy level 2. 2, except now we're on the P block, 2p6. So now I'm at neon, because I've got 10 electrons. I still have to account for 19 more. Okay? So then we're going to go down to the third level. Because now if you look at that periodic table up top, and again I'm looking over there because that's my periodic table, I'm on energy level 3. When we start a new energy level, I always start off on the S block, the S subshell or suborbital. So 3s, how many can it hold? 2. So now I'm at 4, 10, 12. I still have a ways to go yet. I think I have 17 left. So work your way across. Still on energy level 3. We're now on the P block, which can hold 6. 3p6. So now I've got 4, 10, 12, 18. I still have to get to 29. So I still have 11 left if my math is correct. So now I'm done the third level so far. So now pretty much I would be at 2, 4, 10, 12, 18. I'd be at argon right now on the periodic table. So I would go over to group 18, period 3, and look at that blank periodic table. I just completed the 3p block. The P block is on the right side. Now we're getting into the fourth level. Fourth level. Again, watch this. 4. What's the first block we'll always start off with on a level? S. 4s2. 4s2. And now, here's the exception. Here's a little trick. Transition metals. So now I'm right at where calcium would be. Now if you notice where copper is located on the periodic table, it's a transition metal. That block, you should see on your paper, we go back down to 3D. That D block. So pretty much what happens is this. The first level can hold 1. Second level can hold up to 8. Third initially can hold up to 8. But we still have a couple spots left. So we open up 4, energy level 4, and then to accommodate the transition metals, we leave some spaces open. We leave how many? We leave 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We leave 10 open for the D block. So we go back down to 3. Watch this. I'll write it in special color. 3, and I'm going to move it over 3, D. And I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, D, 9. This is the transition metal. So again, we open up level 4, but there's still some space on energy level 3 for some of the transition metal electrons that go on energy level 3. Okay, so overall, this is the configuration for copper. Okay, so again, that's your answer right there. Okay, that's the first set. You guys try the remaining ones. Okay, next part. And we'll talk a little bit about that transition metal issue in class. So now we're going to look, so take a look at that answer. Okay. Let's go down to the second set. We've got I'm going to give you the electron configuration. 1s2, 2s2, 2p6, 3s2, 3p2. Very easy, very easy. Count the electrons. 2, 4, 10, 12, 14. 14 electrons. First level can hold 2, and that's the capacity, S block, 2 per level. The second level can hold 2 plus 6 is 8. 2 in the first suborbital, 6 in the p suborbital, subblock. So a total of 8 on the second energy level. Now we're opening up to the third. 2 in the first, that block is closed. Now we're in the p block, 2 out of 6. So we've got 14 electrons. So we go to atomic number 14. This is going to be silicon. That's the configuration for silicon. Okay? In fact, I'll do 3 and then I'll go back to number 2. Go down to number 3 real quick. 1s1, 2s1. Follow your paper. So now, first, whoa, sorry, that's 1s2. I was going to say that was an incorrect one. First level can hold 2. Second level only has 1 out of the 2. So how many electrons do I have? 3 electrons. That would be lithium. Okay? That's an easy one. Now go back. 1s2, 2s2, 2p6, 3s2, oh boy, 3p6, 4s2, back to 3d10, so we're going to go through the transition metals, that D block of the transition metals, all the way over to 4p6. Okay, so let's look here. Energy level 1 can hold 2 in the s suborbital. Energy level 2 can hold 8. 2 in the s, 6 in the p. So we're now on the energy level 3. So look at that black periodic table, 3s part. We're sodium magnesium mark. 3s2, 3p6. So now we're at 8. That 3p6 argon has a full outer shell. It has 8. It fulfills something called the octet rule. Has 8 valence electrons. It's stable. But we do have room for 10 more to come back in. But we got to go to the 4th level first. 4s2, or potassium, K, and CAR, calcium. Back through to the transition metals from scandium all the way over to zinc, 3d10. Now we're back over at Ga, gallium, for the P block, 6. 1, 2, 3, 4, 5, 6 in the 4th level, we currently have krypton. So this answer is krypton, Kr. And here's the cool part. Ready for this? So the first level, the first energy level has 2 electrons. The second level has 8 electrons. Right here. First level has 2. The third level, octet rule to argon has 8. 8 plus room for 10 more to account for the transition metals. 10, here's that exception, for a total of 18 electrons. And that might be cut off a little bit. Third level is 18. I don't know if that's cut off or not. I'm on a one-man show here. 4th level. 4th level. 2, where potassium and calcium are, plus 6. Octet rule followed. Krypton. 8 electrons. It's stable, but you're going to learn eventually when we go past that, you're going to have a D block 4D10 eventually. Okay, but you'll get to that on the harder ones. So there you go. So the third level technically can hold up to 18 once you pass argon. Okay? Can hold up to 18, but 8 fulfills what we call an octet rule. It's stable. But when we get the transition metals in, you take it one level further. Okay? So there's krypton there. Write that down if you're unsure. And you guys try the rest of those. Now let's take a look at shorthand. This is fun. Shorthand way. Okay, now we've got palladium. Let's do silicon first. Let's do silicon first. No, we'll go to palladium. Let's do silicon. silicone has 14 electrons. So the rule for shorthand is this. Bracket the previous noble gas. And in this case, right above silicone, if you take a look, the previous noble gas is neon. So you would bracket neon, and that's the 2p6. We're on the last one second. And you would start at 3s2, sodium magnesium, and go all the way over to silicon, 3p2. So this right here saves you from writing 1s2, 2s2, 2p6, double check, yep, 2p6. This right here is assumed in there, assumed. And then you have the remaining ones. So when you write it shorthand, you take the previous noble gas and go from there. And on your test, you can use the back of that periodic table, except I'm going to give you another one. I'm going to cover up that one part with the ionization energy. We're going to learn that later this week. So there's the shorthand way of doing it. Here we go. Let's do another one. Right. I'll give a hard one. We can go over this one in class. Palladium, PD. Oh boy. Going down to palladium. Palladium. PD is located in period 5. Fifth row. Oh, a transition metal. This could get ugly. Okay. So what's the previous noble gas? So we're in period 5, so we got to go back to the end of period 4. So the shorthand way is krypton, bracket that, krypton. And now you're in period 5. So you're going to write this, 5s2, because that can only hold 2. 5s2. Now similar to the D block for the top row, for the top period of transition metals, we go back to 4. And now we're in the D block. Follow the format. D, and then you count to palladium. Palladium's going to go 1, starting with Y, yttrium, zirconium, niobium, molybdenum or molybdenum, technetium, ruthenium, rhodium, palladium, PD. So you're left with 4D, how many? 1, 2, 3, 4, 5, 6, 7, 8. And that's the shorthand way. So instead of writing out 1s2, 2s2, 2p6, 3s2, 3p6, where are we at? 4s2, 3d10, that's that transition metal, 4p6, up to 4p6, and that gets me to krypton, 4p6. Instead of all that, we assume that with this, continue on a 5s2, 4d8. Okay? And there you go. Try those. And again, get your hands dirty. Try them. We'll work on them class. We have time this week. That's the shorthand way. So the shorthand way again, take the previous noble gas, bracket it, and continue from there. So the longhand way would be this, and then that. The shorthand way, go to the previous noble gas to that. Okay, so you see that difference there. Okay? And again, S block holds up to 2, P block holds up to 6, D block holds up to 10, F block, oh my gosh, holds up to 14. We'll get to that. Okay? Here's your shorthand way. And then last but not least, ions. Ions. Calcium. Calcium 2+, because that forms, it's a cation, positive ion, tends to lose 2 valence electrons. Start off with calcium. You're going to start off at, this gets so easy, 1s2, 2s2, 2p6. Okay, so now I'm at neon. Now I open up the third level, 3s2, 3p6, because S can only hold up to 2 on each energy level. P can only hold up to 6 on each energy level. So now I'm at 3p6. So now I'm at 2, 4, 10, 12, 18. I need 20. So then I'm going to go up a new energy level to 4s2. There's my 2 valence electrons right here for calcium. Well, when calcium becomes a cation to lose 2, what happens? We get rid of this. And then it takes on this identification, this relation, 1s2, 2s2, 2p6, 3s2, 3p6. Oh my gosh. That looks just like argon. Well, it does. Because argon's got that full outer shell below energy level 4. But here's the thing. You must show that this is what we mean right here is not argon. We show calcium lost 2 valence electrons. Okay? Because again, argon's got the full outer shell. Well, this calcium does, as the cation loses 2. And here its valence electrons, this new shell. 8. But it gave it away to another substance to make an ionic compound. Okay, there you go. And then I'll show you one more. Chlorine, chloride, that's an easy one. Look down here. Here's chlorine, here's chloride. Here we go. Start off, this is so easy. We got, by the way, for chlorine, the atomic number is 17, so we got 17 electrons. 1s2, 2s2, 2p6. I'm out of room on the 2, it can only go up to 8. Open up a new level, 3s2, 3p, hold on, 6. Did I go past 2, 4, 10, 12, 18? Whoops! Whoops! It's a halogen! That's argon. 5. Okay, 1 away from becoming stable. 2, 4, 10, 12, 17. Here's your valence electrons, right? 1 away from becoming stable. Okay? So to show the ion, the anion, we gain 1 electron. It goes as such. Same thing. 1s2, 2s2, 2p6, 3s2, 3p6. So it mimics the noble gas because it has a full outer shell. It's stable. All I want for science is a full outer shell. Yeah, full outer shell. Woo! Full outer shell. Gee, if I could only have a full outer shell, then I could be a stable substance. There you go. Okay, have a blast, have fun. We will show you in class, whether it's today or tomorrow or whatever, the other way, the diagonal way, which kind of acts as a roadmap to make sure you don't skip any levels or suborbitals. And we'll talk more about that in class. All right, get that whole thing done. Let's go. This is good stuff. This is good stuff. This will give you more of a comfort level in high school. Help you out, help you learn. Okay, there you go. I'm signing off. Bye.